Module 2, FlexiGas DS. Introduction to pre-sleeved and pre-ducted products. All UK CSST manufacturers offer pre-ventilated versions of their standard CSST. The primary purpose of all pre-ventilated CSST is to allow the tubing to pass through unventilated areas more easily. All come pre-manufactured with a duct already in place, covering the entire length of pipework from start to finish. The idea is you can use this to pass through unventilated voids, as if it were already running inside a duct. However, there are some big differences between the brands, and there are two major subtypes to consider. Let's label the first type double covered. The first type is made from standard CSST, wrapped first in a yellow cover, and then wrapped again in a secondary additional yellow cover. Some examples of this subtype include Track Pipe CC, Gas Type P2 and GFS P Max. The second subtype, which let's label hard-shelled, are made from standard CSST plus a second hard protective outer shell. Additionally, there is a larger gap between the layers, such that air or gases can circulate more freely. Some examples of this subtype include FlexiGas DS and GFS Plus. There are some great advantages to using a pre-ventilated product, but there is a lot of confusion in the UK about what pre-ventilated CSST products are for and where they can be used. But before we get into the detail, we'll start by busting some common myths about pre-ventilated CSST. Myth number 1. Under the gas codes, the way you ventilate CSST and copper are different. Busted! All gas pipework in the UK needs to be ventilated in exactly the same way, and nothing in UK gas codes treats CSST differently to copper tube. Myth number 2. CSST requires a second cover to meet installation requirements. Busted! This claim can be wrongly circulated to play off market confusion around what these pre-ducted CSST products are meant for. Myth number 3. Pre-ducted CSST products allow passage through all unvented areas without further consideration from the gas installer. Busted! Using any pre-ducted CSST product is not carte blanche to place the product through unvented areas with no further thought. The gas installer must still consider whether this unvented void needs to have a fire rating. The installer must also consider whether the product chosen provides adequate ventilation of the gas pipework for their specific installation scenario. Understanding relevant UK standards and how they relate to pre-ventilated CSST products. To help resolve some of the confusion, first let's consider some key points from BS 6891. The word pipework is used heavily throughout BS 6891, and this word refers to the BSI-approved tubing system chosen by the installer. For example, it can be copper, CSST, or other allowed materials. Importantly, when referring to copper, the word pipework means just the copper tube without any kind of cover. However, for CSST, the word pipework also includes the yellow protective cover, which protects the stainless steel from bleach and the like. I.e., though different piping materials, both are considered gas pipework. This ties into a key lesson from the first module. All gas pipework has to meet the same installation requirements, whether it's copper or FlexiGas or any other CSST brand. Looking at a different part of the installation standards, BS 6891 defines a duct as an enclosed space specifically designed and constructed for the passage of building services. Then later, in section 8.16.1, it goes on to define the requirements on how to use a duct to ventilate gas pipework, if indeed it's required. It's that in many cases, gas pipework already has sufficient ventilation, but where no ventilation exists, it can be provided by using a duct, according to this section. BS 6891 then defines the minimum permitted ventilation opening of the duct in Table 6. You will note that a duct with less than 0.01 meters squared is permitted to have a minimum free area of nothing. This leads to an odd conclusion, that infinitely small ducts are permitted, with no minimum free area required. More on this later, but let's keep going looking at the standards. Another keyword in BS 6891 is sleeve. Do not confuse the word sleeve with duct. They are very different things and for different purposes. BS 6891 defines a sleeve as a protective pipe forming an annulus embedded in the structure, through which pipework can be inserted and withdrawn. The purpose of a sleeve is very different to a duct, and principally they're used to allow gas pipework to pass through solid walls, floors, or other structural elements, or to provide additional protection to the gas pipework if necessary. What is FlexiGas DS? FlexiGas DS consists of our standard CSST tubing or pipework with its yellow cover and a separate secondary outer duct or sleeve layer made from a hard protective shell. Please note a couple of key features of FlexiGas DS. 1. The second layer is a hard plastic shell to protect the gas pipework inside. 2. There is a significant space or annulus between the layers, allowing gas to ventilate freely. And 3. The tube inside can slide in and out over medium-sized lengths. As FlexiGas DS comes already encased inside a secondary gas-tight shell, it can be used as a duct to pass through certain unventilated areas. Additionally, as FlexiGas DS also has a hard outer shell, which also meets the definition of a sleeve, it can be used to provide additional protection to the tube, pass through solid walls or other structures where sleeving of the gas tube might be required, used in the ground or concrete screed or similar, for example where there might be a requirement for the gas tube to be removed or protected from movement. Why do we design FlexiGas DS differently to other pre-ventilated CSST products? While acknowledging that all pre-ducted CSST products meet BSI regulations, we designed FlexiGas DS with a couple of extra things in mind. 1. To include a ventilating annulus between layers. Paper-thin ducts might not make the most sense, even if permitted by installation standards. FlexiGas DS has a 2 to 3 mm annulus between layers, and it more closely resembles ducting, through which you might feed copper or standard CSST. 2. Reduced chance of damage to the duct layer. FlexiGas DS is manufactured with a hard plastic outer shell. This is so that the product is more robust and can be pulled through unvented areas more easily. If you remember from the first module how easily the yellow cover can rip, it stands to reason that a second yellow cover as a duct could rip just as easily. Even if the outer polyethylene cover of FlexiGas DS does rip, it does not mean the ventilation is lost, as it's still protected by the hard corrugated PVC shell. 3. Reduced potential for puncturing multiple layers. If damage occurs, the gap between layers is more likely to protect the gas pipework inside. 4. Increased venting in a worst-case scenario. If a full puncture does occur, gas can more easily move between the layers and escape to a vented area, and be detected before a dangerous buildup of gas in the unvented area can occur. If the duct is too small, a buildup of gas in the unvented area will happen more quickly. 5. Not too big, not too small, but just right. While the FlexiGas DS annulus is big enough to properly ventilate gas if needed, it's also not so big that the inside FlexiGas tubing layer is not properly supported inside the duct. The annulus of 2 to 3 mm is similar to a Munson ring, and FlexiGas DS is 100% suitable for vertical unventilated risers. Pre-ventilated CSST versus normal ventilation. As we discussed in the previous sections, the primary purpose of pre-ventilated CSST is to allow it to more easily pass through unventilated areas. But let's also consider how unventilated areas were tackled before these products existed, or how is it still done with rigid tube like copper. Historically, installers would provide advantageous ventilation by placing vents, building custom ducts, or utilizing existing ducts when passing through unventilated areas using standard CSST or rigid tube like copper. Examples of this might include building a custom duct, putting the gas tube inside a flexible conduit that can act as a duct, or by providing ventilation to a previously unventilated area, for example by installing a grill or vent. These older methods of ventilation are just as valid as using a pre-ventilated CSST product like FlexiGas DS, and in many cases can be more cost-effective, as you only need to provide ventilation or a duct for the unvented section, rather than ventilating the entire length of the gas line in sections where it might not be necessary. Important note: if you choose to ventilate your gas pipework using these traditional methods, or if your gas drawings are showing the run as having ventilation, then a pre-ventilated product like FlexiGas DS is not required. FlexiGas DS can, however, offer a lot of convenience if traditional ventilation methods are difficult or costly. Installing FlexiGas DS. While FlexiGas DS is not for every installation type, there are situations where FlexiGas DS can save a lot of time and work on site. For example, using FlexiGas DS in a new build with a high number of unvented areas or solid structures that require sleeving can save significant labor time. The installation process of FlexiGas DS is similar to that of standard FlexiGas, with a few added steps to accommodate the outer sleeve casing. Step 1. Cut the sleeve. Use the FlexiGas Knipex sleeve cutter to cut through the outer sleeve of the FlexiGas DS. Carefully slide the sleeve apart to reveal the inner FlexiGas tubing. Step 2. Cut the inner CSST. Using a wheel metal pipe cutter, make a clean and circular cut in the FlexiGas tubing, making sure to center the cut in the valley between corrugations. Step 3. Remove the cover. Using a utility knife, remove a section of the flame retardant yellow cover from the inner FlexiGas tubing, exposing the last 4 corrugations. Leave the outer sleeve intact. Step 4. Place the duct cap, optional. For a neater appearance, use an optional duct cap to center the FlexiGas tubing within the sleeve. Step 5. Place on FG wrap, optional. This step if using the FG wrap feature, otherwise tape later. If using FG wrap, make sure it's inserted in the correct direction. Step 6. Slide on the nut and collars. Slide the nut over the tubing and place the 2 semicircular collars around the tubing, making sure the ridges on the collars sit in the last 3 valleys of the tubing. Step 7. Tighten for a secure seal. Using 2 suitably sized wrenches, tighten the nut and fitting. Make sure to use enough torque to fully flatten and compress the last corrugation against the fitting seat. Step 8. Tightness testing. As in the previous module, this step is the time to conduct gas tightness testing. Do not proceed to further steps until the entire gas line has been purged and tested. Step 9. Wrap the tail. After conducting a gas tightness test, wrap the small gap between the tail of the nut and the tubing with yellow silicone tape. Or if using FG wrap, place the cap onto the tail, secure in place with a quarter turn, and then unroll. Step 10. Attach FG bond, optional. Place the warning notice between the earthing terminal and the nut, and then attach the earthing terminal to the nut. Strip the earthing cable to reveal 1 to 2 centimeters of copper wire and screw it down onto the wire. Remember, if not using FG bond, then some other earth bonding method is required. Using FlexiGas DS as a duct. FlexiGas DS can be installed through both vented and unvented areas, but the outer layer can be adjusted to suit the specific requirements of the installation. Option 1 is to run the outer second layer end-to-end, i.e. by leaving the FlexiGas DS layer in place for the entire run, from the gas meter to the gas appliance. FlexiGas DS can be laid straight into an unvented area and clipped on the outside as normal using metal Munson rings. Run the outer second layer from just short of the gas meter all the way to the gas appliance. In this way, FlexiGas DS will pass through both vented and unvented areas. Option 2 is to remove long sections of the outer cover, such that the second layer of FlexiGas DS remains only in the unvented area. There might be a range of reasons for choosing option 2. You might want to reduce the diameter size in vented areas. You might prefer the aesthetic of the single tube. But importantly, removing the second layer back to the start of the unvented area reduces the distance between the unvented area and the vented area in case of a gas leak. Removing longer lengths of the second layer. Longer lengths of the second layer can be removed by cutting the tube with the FlexiGas Knipex cutter and removing it as necessary. About 10 to 15 meter lengths can be removed in one segment. If you need to remove longer segments, you can cut the FlexiGas DS layer into separate 10 meter segments, such that the longer lengths can easily be removed. Installing a duct cap. A duct cap can be installed to maintain a neat appearance and ensure proper functioning of the duct. Unventilated voids that require a fire rating. Let's go back quickly to BS 6891, section 8.16.2. This section says, the fire resistance of any duct containing pipework shall have a fire rating equal to or greater than any void through which it passes. This is a really important section that is commonly misunderstood. Many unventilated voids might be a location where a fire rating is required. If the unventilated void requires a fire rating, then none of the existing pre-ventilated CSST systems can be used, as all manufacturers use a plastic cover or shell for their ventilation, which will of course melt in a fire. As always, remember rule number 1, i.e. if you were working with copper and the unventilated area you were trying to cross required a fire rating, you would put the gas pipework inside a metallic or fire-rated duct and not plastic sleeving. The same applies to CSST. Using FlexiGas DS as a sleeve. FlexiGas DS outer layer serves as a protective barrier and can be used in a number of different contexts. One example is for passing through solid walls, floors, or other structural elements, where protection or possible removal of the inner FlexiGas might be a requirement. Another is for passing through the ground, under driveways or in screed, where additional protection of the tube is needed. Cutting a segment out of FlexiGas DS second layer. In some cases, you might need to remove a section of the FlexiGas DS outer sleeve and expose the inner CSST layer. To do so, follow these simple steps. 1. Mark the segment. Identify the segment of the outer sleeve you want to remove and mark the start and end points with a permanent marker. 2. Circular cuts. Using the Knipex cutter, make 2 circular cuts at the marked points. Ensure the cuts go through the outer sleeve without damaging the inner FlexiGas layer. 3. Remove the segment. With scissors or shears, carefully cut along the length of the outer sleeve between the 2 circular cuts. Remove the cut segment to expose the inner FlexiGas layer. This technique is particularly useful in situations where the inner FlexiGas layer needs to be sealed, such that fire mastic or similar applied directly to the gas pipework. By cutting and removing a segment of the outer sleeve, you can easily access the inner CSST layer to make any necessary adjustments or seals. Supporting FlexiGas DS. Supporting FlexiGas DS is similar to supporting standard FlexiGas. Follow the guidelines outlined in the table below for proper support and spacing. To support FlexiGas DS, 1. Attach a Munson ring. Place a Munson ring around the outer sleeve of FlexiGas DS, ensuring it is positioned correctly according to the support spacing guidelines. 2. Tighten the Munson ring. Tighten the Munson ring as you normally would for standard FlexiGas. Thanks to the robust outer layer of FlexiGas DS, there is no risk of over-tightening the Munson ring and blocking the ventilation inside. One quick caveat on one location where you cannot use FlexiGas as a sleeve. Where FlexiGas DS is passing through a solid wall or floor to enter an unventilated void, it should be placed inside a small additional protective sleeve. This is because, according to BSI, a named feature of a product cannot be 2 things at once. For example, in an unventilated void, the outer DS layer is fulfilling the purpose of a duct, and so can also be a sleeve. Note, according to BSI, a large metallic duct passing through an unventilated void and then through a solid wall also needs to be encased in another sleeve layer as it passes through the solid wall. In all other locations, the outer layer of FlexiGas DS can be used as a sleeve. This concludes Module 2. There will now be a short quiz on the material covered.